Introduction to pH, pOH, H plus concentration, OH minus concentration, Kw, Kb, Ka, pKa, pKb. H plus H2O will give H3O plus. The H plus is a proton, that's proton, and the H2O is water. The H3O plus is hydronium ion. We can write the concentration of H plus, that is mole over volume, and the concentration of hydronium ion. These concentrations are mole over volume and mole over volume in the same volume. These two are equal to each other. So you can represent H plus as hydronium ion, or you can just write H plus. Or you can write hydronium ion as H plus. Both are equal to each other. They are the same. The H plus has a vacant orbital. An orbital is the probability of finding an electron. So this hydrogen has lost its electron, and its orbital is 1s orbital. The water, here's the structure of water with the two lone pairs, and these lone pairs will donate the 2 electrons to the H plus orbital. This donation of electron is called coordinate bonding or dative covalent bonding or bond, and that will form H plus bonding to oxygen, bonding to hydrogen and another hydrogen, and there will be plus here. The plus is brought forward from H plus to the oxygen, or you can find the oxidation number of oxygen using the formal charge formulae. And if you use a formal charge, it's going to be the formal charge. We got formal charge will be equal to valence electron minus bonding electron minus lone pair electron. The valence electron for oxygen is 6 because it's in group 6. That means it's got 6 electrons in the outer shell. So that's 6 minus how many bonding electrons? We can count it 1, 2, 3. So we can write that here. 3 minus how many lone pairs? So it's got 1, 2 left because it has used those 2 electrons here. Now it's got this left. So that goes there. And so we have to do minus 2. And that gives plus 1. And that's the plus 1 here, which we have there. So Fc is formal charge and Ve is valence electron. That means our number of electrons in the outer shell. Be is bonding electron. That means the number of electrons in a bond, but there are 2 electrons in a single bond, so we count that as 1 in this case. That's why it's 3. 1, 2, 3. That's why we got 3 there. And we've got, finally, we got the lone pair electron, and the lone pair electron we've got is 2, 1, 2. The ionic equation for acid and base is H plus OH minus to give you H2O. Remember, H plus concentration is equal to H3O plus concentration. Basically, H plus is H3O plus. With this ionic equation for acid-base reaction, you get salt and water, but the elements of the salt are what we call the spectator species. So they will cancel out, and you're left with H plus OH minus plus H2. That gives you H2O. Let's give it a try. So acid, HCl plus sodium hydroxide will give you sodium chloride plus H2O. Because these are aqueous, that will be aqueous. This solid will dissolve in solution because it's a salt, so that will be aqueous, and water is liquid. So we can split it up because it's aqueous. We can write H plus Cl minus sodium hydroxide, sodium plus OH minus to give sodium plus Cl minus plus H2O. This is the acid, hydrochloric acid in water. This is sodium hydroxide in water. This is salt in water. The aqueous means water and plus water. But the H plus Cl minus here, we cancel Cl minus there. Sodium plus, we cancel sodium plus there. And now you're left with the H plus OH minus to give you water. And we call that ionic equation. And the ionic equation for acid-base reaction will give you water. Now we can find out the concentration of acid in the solution, or we can find the concentration of base in the solution. Once we find the concentration, we want to find out how acidic that might be or how basic that might be. The base here is an alkaline base. Alkaline base is a soluble base. That means an alkaline base is a base that dissolve in water. That's the definition of an alkali. An alkali is a base that dissolve in water. Alkali is a base that dissolve in water. So if you have a concentration of 0.1, that's 10 to the power minus 1, and the pH value for that is 1. Concentration of 10 to the power minus 2, 10 to the power minus 2 is 0.01, that's 1 over 100, and the pH is 2, 1. 10 to the power minus 3 is 1 over 1,000, and that's 0.001, and so pH is 3, and that goes on like that. All the way to 10 to the power minus 14, pH is 14. To 10 to the power minus 13, pH is 13. 10 to the power minus 12, pH is 12. 10 to the power minus 11, pH is 11. Below 7 is acidic, and this is the strongest acid 1, and the weakest acid is 6. Above 7 is alkali base, and 8 is weak base, 14 is strong base. 7 is neutral, so pH equals to minus log of base 10 concentration of H plus. And so if I put pH equals to minus log of base 10 concentration of 0.1, I'm referring to that concentration here. I'll put it there. The answer to that will be equal to 1. So this is the formula we can use to find the pH. That means how many, well, it gives you the value of concentration of the hydrogen ions. So it's telling you whether it's strong acid. If it's a strong acid, which means it will dissociate completely. And if it's a weak acid, it will partially dissociate. So that's the definition of a strong acid. Strong acid dissociate completely. Weak acid dissociate partially. That means not fully dissociated. We can find the pOH of a base by putting minus log base 10 times the concentration of OH minus. So this value will tell you whether it's a strong base or a weak base. So to calculate the pOH, we use this formula. pH plus pOH equal to 14. This is the relationship between pH and pOH. If we know the pH, we can find the pOH by taking away pH from 14. If water dissociate, so we get H plus plus OH minus, and we can write the Kc, that's equilibrium constant, and we can write the Kc equilibrium constant, which is Kc equals to concentration of H plus times the concentration of OH minus divided by the concentration of H2O. Remember that Kc is equilibrium constant. If I multiply both sides by water concentration, I get Kc times the concentration of water equals to concentration of hydrogen plus concentration of OH minus, and the concentration of water times Kc is called, we have a special name for that, we call that Ka, and that meant that Ka equals to concentration of H plus times concentration of OH minus, and sometimes we call it Kw because this is the dissociation of water. So not just an acid in this case, which is what that is, but any acid, this is water. Instead of calling it Kc, we can't call it Kw. So we're going to stick with Kw because it's water dissociating. So we can write Kw equals to concentration of H plus times concentration of OH minus will be equal to 10 to the power minus 14. But don't forget, it's water dissociating. So we're going to have H plus equal to OH minus concentration, which meant that we can call them X. So I can now put X into here. So X times X will become X squared equals to 10 to the power minus 14. And therefore, X will become root 10 to the power minus 14. And that equals to, well, root, we know what root is. So that's 10 to the power minus 14 all to the power a half, because that's what root is, power a half. And we're going to get 10 to the power minus 14 over 2. And that equals to 10 to the power minus 7 for X. What that meant is the concentration of H plus for water is 10 to the power minus 7, and the concentration of H plus for the base, OH minus for the base, concentration of OH minus for the base in water is 10 to the power minus 7, and when you multiply them together, you get 10 to the power minus 14. Concentration of H plus times concentration of OH minus for water is 10 to the power minus 14, and we call that kW. So this is the new equation that we need to remember. If we know Ka of any acid, we can find the pKa, which is minus log base 10 times the Ka. Likewise, if we know the Kb, we can find the pKb. Again, that will be equal to minus log of base 10 Kb. This is equilibrium constant for acid, and this is equilibrium constant for base. We can find the pKa of acid, and we can find the pKb of base. A for acid, B for base. pKa plus pKb equals to 14. That's one relationship we need to remember. Another relationship we can remember is Ka times Kb equal to 10 to the power minus 14. That's another relationship that we should remember. pH equals to minus log base 10 concentration of H plus. We can find the concentration of H plus by multiplying both sides of this equation by minus 1, which means I get minus pH equal to log of base 10 concentration of H plus. Now to find concentration of H plus, we raise 10 to the power minus pH, and the answer will be equal to concentration of H plus, which means I get concentration of H plus equals to 10 to the power minus pH. And this is the new formula we need to remember, how to find the concentration from pH. We can do the same for finding the concentration of OH minus if we know the pOH. For pOH equal to minus log base 10 concentration of OH minus, we can find the concentration of OH minus, multiply both sides by minus 1, we get minus pOH equal to log base 10 concentration of OH minus, and finally we raise 10 to the power of minus pOH, and the answer will be equal to the concentration of OH minus. We can write concentration of OH minus equal to 10 to the power minus pOH, and that's how you find the concentration of OH minus from its pOH. pKa equal to minus log base 10 Ka value. In order to find the Ka value from its pKa, we multiply both sides by minus 1. We get minus pKa equal to log base 10 Ka. Now we can raise 10 to the power minus pKa, and the answer equal to Ka. So we write 10 to the power minus pKa equal to Ka. And that's how you find the Ka from its pKa. The top one is logarithm, and the bottom one here is exponential function. And the top one is logarithm function. So you can interchange between logarithm and exponential function. What about pKb? pKb for the base is equal to minus log base 10 Kb value. Again, we need to multiply both sides by minus 1, minus pKb equal to log base 10 Kb. Now we need to raise 10 to the power minus pKb, and the answer equal to Kb. We get 10 to the power minus pKb equal to Kb. That's how you find Kb from pKb. Summary: pH equals minus log base 10 H plus concentration. H plus concentration equals 10 to the power minus pH. pOH equals minus log base 10 concentration of OH minus. OH minus concentration equals 10 to the power minus pOH. H plus concentration times OH minus concentration equals 10 to the power minus 14, and that equals kW. pH plus pOH equals 14. pKa equals minus log base 10 Ka. Ka equals 10 to power minus pKa. pKb equals minus log base 10 Kb. Kb equals 10 to power minus pKb. Ka times Kb equals 10 to power minus 14. pKa plus pKb equals 14, just like pH plus pOH equals 14. Concentration of H plus times concentration of OH minus equals 10 to power minus 14, and that's Kw. Ka times Kb equals 10 to power minus 14. So easy to remember them.